You probably felt it before you could explain it. That weird sense that the pace is no longer speeding up in a straight line, but bending, like gravity changed, like the future is pulling harder than the past. That is the feeling Jensen Huang has been pointing at. And when he talks about the next phase of AI, he is not describing a feature update. He is describing a change of state, a phase change, the kind where the same atoms behave like a completely different substance. And you can see exactly what he means if you track the sequence of waves he keeps referencing. We went from perception AI, where machines learn to recognize patterns in images and sound, to generative AI, where machines learn to produce text, code, images, and audio, and then to agentic AI, where systems do not just answer but plan, decide, use tools, and execute multi-step goals. At GTC 2025, Huang explicitly framed the progression as computer vision to generative to agentic, and then pushed the conversation into robotics and physical AI. That last phrase is the hinge, physical AI. Because physical AI is what happens when intelligence stops being a suggestion and becomes a force in the real world. When it is not only generating words but generating actions. When the output is not a paragraph but a robot arm moving through space, a warehouse reconfiguring itself, a factory learning new motions overnight, a supply chain rerouting in real time, a surgical instrument assisting a human, a machine in a field making decisions about water and soil and pests while the sun is setting. That is the next phase. Not smarter chat, not nicer images, intelligence that touches atoms. That is why Jensen keeps returning to the same mental model. Factories. In the last industrial revolutions, factories took in raw materials and energy and produced goods. In this one, factories take in data and energy and produce tokens, decisions, plans, and actions. NVIDIA's own messaging around Blackwell leans into the idea that we are entering a new era of computing where these systems power AI training and real-time inference at extreme scale. But to understand why the next phase changes everything, you have to understand the bottleneck it removes. The bottleneck was never the creativity of humans. The bottleneck was the cost of intelligence. When intelligence is expensive, you ration it, you centralize it, you make committees, you make forms, you make slow decisions, because decisions are costly to produce, costly to validate, costly to coordinate. When intelligence becomes cheap, the entire structure of organizations, markets, and even nations rearranges, because the advantage shifts from who has the smartest people to who can run the fastest learning loop. And this is where Jensen's hardware talk becomes a story about power in the deepest sense. Blackwell is not just a faster chip. It is an attempt to collapse the cost curve of intelligence again, right as the old free lunch died. The Blackwell GPU is designed as a dual-die superchip at the reticle limit, connected by a 10 terabytes per second chip-to-chip interconnect, so the system behaves like one GPU. That matters because in modern AI, moving data is often more expensive than computing. If you cannot keep model weights and activations flowing fast enough, you waste your most precious resource. Time under training, time under inference, time before your competitor ships. So NVIDIA attacked the bottleneck where it actually lives. Memory bandwidth, interconnect, low precision compute formats, and system-level integration. Blackwell's platform positioning and technical description emphasize scaling to extremely large models and accelerating both training and inference. Now take that and connect it to agentic AI. Agentic AI is the moment the model stops being a static answer engine and becomes a dynamic system that can hold a goal, break it into steps, call other tools, check its own work, and keep going. The economic implication is brutal. The unit of labor changes. You no longer hire only for hands that execute tasks. You hire for minds that define objectives, constraints, and taste, while the execution layer becomes automated, scalable, and available on demand. And when that layer becomes cheap enough, the world does not just get more productive, it gets reorganized. Because if you can spawn 1,000 tireless cognitive workers for pennies, the bottleneck becomes the quality of your direction, not the quantity of your effort. The bottleneck becomes whether you can ask the right questions, define the right reward signals, choose the right data, set the right guardrails, and decide what matters. In the early software era, being able to code was power, because you could tell machines what to do. In the generative era, being able to talk clearly to machines becomes power, because you can tell systems what you want, and the system fills in the how. In the physical era, being able to define safe, ethical, high-impact objectives becomes power, because now the machine can act. And Jensen's worldview has always been about removing barriers so that more people can build. He has repeatedly pushed the idea that the most valuable advantage shifts toward domain expertise and problem framing as the tooling becomes more accessible, an idea echoed in the uploaded script material you provided. Digital AI can be wrong, and you can recover. A chatbot can hallucinate a paragraph and you can delete it. A code assistant can generate a bug and you can revert the commit. Physical AI can be wrong and something breaks. So the next phase forces a marriage between two worlds that rarely respected each other: the probabilistic world of deep learning and the deterministic world of engineering safety. That is why simulation becomes non-negotiable. If you cannot safely learn by failing in reality, you learn by failing in a high-fidelity synthetic world first. That is the logic behind digital twins and industrial simulation platforms. At GTC 2025, Huang highlighted simulation tooling and collaborations around robotics and physical AI, including omniverse and physics-based simulation efforts. And this is also why you are hearing a flood of announcements around physical AI models for robots. NVIDIA's news release in early 2026 describes new physical AI models and specifically mentions Isaac GR00TN 1.6, described as a vision language action model for humanoid robots built to unlock full body control and improved reasoning. That is not a toy, that is a template for a new category of worker. Imagine what happens when a robot stops being a machine. You program step by step and becomes an agent. You instruct at a goal level. You do not say, rotate joint 1 by 5 degrees. You say, unload these boxes safely. Do not crush anything fragile. Keep the walkway clear and report any damaged items. That is a completely different interface to reality. And when that interface exists, every industry that touches the physical world becomes software, because behavior becomes updatable. A warehouse becomes an app you can improve weekly. A factory becomes a model you can retrain monthly. A logistics network becomes a policy you can optimize daily. Now connect that to the idea of faster than you think. In every previous industrial era, deployment speed was limited by physical rollout. You needed to build railroads. You needed to string wires. You needed to distribute machines. In this era, the intelligence can be distributed instantly once the infrastructure exists, because the new product is not steel, it is behavior. That is why Jensen talks like someone obsessed with infrastructure, not gadgets. The factory is the product. So let me ask you a question that will determine whether you are a spectator or a builder in this next phase. Where do you think the real competition is going to be? Most people will say model versus model, company versus company, chip versus chip. That is not where it will be decided. It will be decided at the level of learning loops. Who can collect better signals, run more simulations, train faster, deploy safer, monitor tighter, and improve continuously without breaking the world. And the reason NVIDIA keeps launching not just chips, but software packaging like inference microservices is because scaling AI into real organizations is not a research problem anymore. It is a deployment problem. NVIDIA NIM is positioned exactly as that missing industrial layer. Packaged inference microservices meant to make production deployment easier and faster across environments. Here is the uncomfortable truth. The winner is not the one with the coolest demo. The winner is the one who can ship intelligence into reality like a utility. And that is why Jensen's next phase claim changes everything. It moves AI from a novelty economy to an infrastructure economy. Now, if you are feeling a little uneasy, good, because that means you understand the stakes. But do not rush to fear yet, because the next part is where it becomes practical. What this phase demands from businesses, from workers, from students, and from nations, and why the biggest mistake is to think this is about learning one more tool. Because once intelligence becomes industrial, your advantage is not what you know. It is how fast you can adapt what you know into a system that acts. And in the next part, I am going to show you the exact mechanism that turns a company into an AI factory, why most AI projects fail right before the breakthrough, and how physical AI forces a new definition of what a job even is. Let's get brutally concrete. Most organizations right now are doing the same thing with AI. They are buying a model, connecting it to a chat interface, showing it to executives and calling it transformation. They celebrate a pilot, they create a slide deck, they announce an initiative, and then nothing really changes. Because the difference between playing with intelligence and manufacturing intelligence is the difference between owning a generator and building a power grid. A pilot is a generator, a factory is a grid. So what does a real AI factory look like? It has 4 layers, and you can't skip any of them without paying later. First, you need the compute substrate, the actual engine that can train, fine-tune, and run models efficiently enough that usage becomes cheap. That is where platforms like Blackwell matter. NVIDIA's own Blackwell description emphasizes dual die integration, massive transistor counts, and extremely high bandwidth interconnect, all aimed at scaling AI workloads. Second, you need standardized deployment so intelligence can be shipped into products and internal processes without every team reinventing the pipeline. That is exactly the problem NIM targets: packaged inference microservices to simplify deployment and scaling of model inference. Third, you need data refinement, because raw data is not intelligence. Raw data is crude oil. Intelligence is refined fuel. That means you need pipelines that clean, label, secure, version, and monitor data, and you need governance that determines what data is allowed to shape decisions. Fourth, you need feedback loops, because intelligence that does not learn from reality becomes stale, and stale intelligence becomes dangerous, especially in the physical world. Now, notice what just happened. This is no longer an AI team problem. This is an organizational architecture problem. It touches IT, security, compliance, product, operations, manufacturing, logistics, customer support, and leadership incentives. It forces a redesign of how information flows. And this is where Jensen's management philosophy suddenly becomes relevant to the technology itself. He repeatedly frames speed of information flow and low latency decision-making as survival traits, a theme that appears strongly in the script material you provided. Blackwell_L_Monstro_day NVI, because in an AI factory, latency is death, not just network latency, organizational latency. If it takes weeks for a problem to reach the people who can fix it, your learning loop breaks. If it takes months to approve a model update, your competitors iterate around you. If your teams hoard data, your models starve. If your incentives punish mistakes, your people hide failures, and your systems never improve. This is why agentic AI becomes a mirror that exposes a company's true operating system. If your company is bureaucratic, agentic AI will amplify chaos because it will execute bad instructions faster. If your company is clear, principled, and feedback-driven, agentic AI will amplify excellence because it will execute good instructions at scale. And physical AI raises the stakes again, because the moment your models control motion, you must solve three problems most companies have never solved simultaneously: reliability, safety, and accountability. Reliability means the system behaves consistently under variations. Safety means the system avoids harm, even when it is uncertain. Accountability means you can trace why decisions happen, who approved them, and what constraints. Blackwell_L_Monstro_day NVI, not optional. In the physical world, mistakes are invoices written in metal and blood and lawsuits and headlines. So the next phase forces something most people have been avoiding. Alignment becomes engineering, not a philosophical debate, an engineering practice. And the reason simulation is central is because it is the only scalable way to generate the experiences physical systems need without destroying the world in the process. This is also why synthetic data becomes a strategic asset. If you can simulate 1 million rare edge cases, you can train for robustness that real-world data will never give you quickly enough. Huang has explicitly tied physical AI's progress to synthetic data and reinforcement learning that teach physical concepts. Now let's talk about what this does to jobs, because I want you to hear this clearly. The next phase does not eliminate work. It eliminates certain categories of work, and it creates categories that did not exist before. The easiest way to see it is to ask, what is the unit of value in a job? In the old economy, value often came from execution capacity. How many tasks you could do, how many hours you could endure, how many steps you could complete accurately. In the AI factory economy, execution becomes abundant. So value shifts toward three things: intent, judgment, and responsibility. Intent is choosing the right goal. Judgment is deciding what good looks like. Responsibility is owning the consequences of action. That is why the most dangerous career strategy right now is to build your identity around being a human version of a procedure. Procedures are exactly what AI systems consume and automate. But if you build your identity around being the person who understands a domain deeply enough to define the right objectives and constraints, you become more valuable, not less. That theme is central in the uploaded Jensen-style scripts, where domain expertise rises as technical barriers fall. Lo que debes estudiar hoy para. Now, here is where the conversation gets uncomfortable for high achievers, because the next phase punishes ego. If you cling to being the smartest person in the room, you will lose, because your system will be smarter at narrow tasks, and you will spend your energy defending status instead of improving outcomes. The winners will be people who can say 3 phrases faster than anyone else. I do not know, show me the data, I was wrong. That is not motivational fluff. That is an operational advantage in a world of accelerating learning loops. Now let's zoom out from individuals to nations, because physical AI makes sovereignty a practical question again. When AI is just a cloud service, you can rent it. When AI becomes infrastructure that shapes your factories, your hospitals, your logistics, your energy systems, your defense, your education, renting becomes dependency. That is why sovereign AI has become a repeated theme in NVIDIA's messaging and Jensen's public framing. and why countries are thinking about building their own AI capabilities rather than relying entirely on external models and external infrastructure. This emphasis is echoed in your uploaded scripts as well. Sovereign AI _ el plan de Jensen. Because if intelligence is a utility, whoever controls the utility, lo que debes estudiar hoy para, now connect that to what NVIDIA is doing with packaging and ecosystems. If Blackwell is the turbine and NIM is the standardized container, then the last missing piece is the integration of AI into every workflow without bespoke engineering each time. That is how you turn intelligence into electricity. And that is why this phase moves so fast. Once the infrastructure is in place, the marginal cost of deploying one more cognitive capability drops, and adoption becomes a flood. This is the part most people misunderstand. They think the revolution happens when the model becomes magical enough. No, the revolution happens when deployment becomes boring, when the hardest part is no longer building the model, but deciding what to do with it, when every team can spin up a specialized assistant the way they spin up a server, when intelligence stops being a project and becomes a layer. Now we arrive at the most important consequence of physical AI. It collapses the boundary between software and operations. In the old world, your software was in your screens, and your operations were in your warehouses and factories. In the new world, software writes behavior into operations, and sovereign AI, el plan de Jensen. You realize why the next phase is not a tech story. It is a civilization story, because the systems that run your supply chain will negotiate with the systems that run someone else's supply chain. The systems that route ambulances will coordinate with the systems that manage traffic lights. The systems that manage power grids will react to the systems that manage data centers. Agentic systems will talk to agentic systems. And when they do, the bottleneck becomes trust, verification, and safety. That is why the next phase creates a premium on standards, auditability, and robust governance, not just raw intelligence. Now here is the cliff edge you need to see coming. Physical AI will not roll out evenly. The companies and countries that build AI factories first will compound faster because their systems will improve daily while others debate. Their costs will drop faster, their products will iterate faster, their talent will become more productive. Their feedback loops will tighten. And that compounding creates a gap that is extremely hard to close later because it is not a one-time advantage. It is a self-reinforcing flywheel. So if you are watching this and thinking, I will wait until it stabilizes, you are making the exact mistake people made with the internet, with mobile, with cloud. Except this time the penalty is harsher, because this is not a distribution shift, it is a cognition shift. And in the final part, I am going to walk you through the hidden mechanism that makes physical AI explode faster than anyone expects: simulation at scale, vision language, action models, synthetic data pipelines, and the moment robots become generalists. Because once that moment arrives, the economy does not just automate tasks, it automates entire categories of coordination. There is a reason physical AI feels like science fiction. Not because it is impossible, but because your brain was trained by a world where intelligence was trapped inside humans and software was trapped inside screens. Physical AI breaks both assumptions. It puts intelligence into systems that move through space, and it turns software into something that can be trained, not just written. So let's talk about the core engine of the next phase: embodied learning. A robot cannot learn the way a language model learns. A language model can digest the internet. It can read billions of sentences. A robot needs experience in a world governed by physics, and real-world experience is slow, expensive, and dangerous. So the only scalable answer is to create experience artificially, at massive scale, and then transfer the learned policy into reality. That is the flywheel. At GTC 2025, Huang highlighted physical AI as the next frontier and tied it to synthetic data and reinforcement learning for robotics. Then, in early 2026, NVIDIA announced new physical AI models, including Isaac GR00TN 1.6, described as a vision language action model for humanoid robots. Vision language action is the key phrase, because that is the bridge between chat and motion. Vision means the system perceives the world. Language means you can give it goals and constraints in human terms. Action means it can output control signals that move a body. When those three fuse into one model family, you get something radically new: a generalist interface to the physical world. Not a robot programmed for one factory line. A robot that can be retasked. A robot that can learn new tasks through demonstration, instruction, and simulation. Now let's make this visceral. Think about how the industrial world works right now. Factories are designed around fixed automation because programming robots is hard and changing them is costly. So we build rigid processes and humans adapt around machines. Physical AI flips the relationship. Machines adapt around objectives. That means factories can become flexible, and flexibility is resilience. It means supply chains can respond like organisms, not like spreadsheets. It means labor shortages change character, because the question becomes not do we have enough hands, but do we have enough judgment, enough supervision, enough people who can define what safe and good looks like. Now, the next phase is not only robots. You can run 10,000 scenarios before you commit resources. You can stress test your factory design before you pour concrete. You can model traffic flow changes before you repaint roads. You can detect bottlenecks before they become failures. This is why the idea of AI factories matters so much. The factory is not just making tokens, it is making foresight. And foresight is the most valuable product any organization can own, because it reduces uncertainty, which is the most expensive variable in business and government. Now connect that to Blackwell and deployment. The reason hardware announcements matter is not because you should worship silicon. It is because physical AI requires massive compute to generate enough simulated experience and to run models fast enough at the edge that they can react in real time. Blackwell's architecture is explicitly positioned around scaling AI training and inference, and its design details emphasize unified dual die operation with extremely high bandwidth interconnect. And on the deployment side, NIM is positioned to make inference production easier by packaging optimized microservices for models. Put those together and you get something that should change how you think about the next decade. The big story is not that models get smarter. The big story is that intelligence becomes distributable. And when intelligence becomes distributable, coordination becomes automatable. That is the step most people miss. They think AI replaces a writer, a coder, a designer. Physical and agentic AI start replacing coordination overhead, scheduling, routing, procurement decisions, quality assurance triage, safety monitoring, predictive maintenance planning, inventory balancing, negotiation between constraints, continuous optimization across systems. A small country can build capabilities that previously required empires if it invests in the right infrastructure and education loops. And that brings us to the most persuasive point Jensen is implicitly making when he talks about the next phase. The scarcity is moving. In the last era, scarce compute was the bottleneck. Now compute is being scaled aggressively, and deployment is being standardized, and synthetic data is expanding experience faster than the physical world can provide it. So scarcity shifts again. Scarcity becomes ethics, governance, and taste. Scarcity becomes people who can set objectives that do not create disaster. Scarcity becomes leaders who can move fast without breaking trust. Scarcity becomes the ability to align systems to human values in messy, real environments. That is why the next phase is not only a technology race, it is a competence race. And if you are thinking, okay, what do I do with this? The answer is not to memorize a tool. The answer is to become the kind of person who thrives when tools change weekly. You do that by mastering a domain, learning to reason from first principles, and building the habit of tight feedback loops. Those themes are repeatedly emphasized in the Jensen-style scripts you provided, including the focus on resilience, first principles thinking, and domain expertise over syntax worship. Last three inversiones más seguras, because in a world where intelligence is cheap, the person who wins is the person who can turn intelligence into outcomes without losing control. Now I want you to picture the moment that is closer than most people admit. A hospital where scheduling, diagnostic support, supply management, and patient flow are coordinated by agents that learn daily. A port where cranes, trucks, customs processing, and container routing are orchestrated by systems that simulate tomorrow's congestion before it happens. A farm where irrigation, fertilizer timing, pest detection, and harvesting logistics are optimized by models trained on local conditions and validated through digital twins. A factory where robots are retasked overnight because the model understands goals, sees the environment, and can act safely. When those become normal, the question is no longer, will AI change everything? The question becomes who built the loop, who owns the infrastructure, and who can steer it. And that is why Jensen's next phase claim is not hype. It is a warning disguised as a roadmap. The world is moving from AI as content to AI as capability, from AI as conversation to AI as coordination, from AI as software to AI as industrial infrastructure, from intelligence that talks to intelligence that touches. And the people who understand this early will not just get ahead. They will set the rules that everyone else has to live under. So here is the final pressure test for you. Right now as you listen, if physical AI is the next phase, then the most valuable skill is not producing output. It is designing behavior. And designing behavior means you must become fluent in constraints, incentives, and consequences. Because the next phase gives you something previous generations never had. The ability to scale las 3 inversiones más seguras. Industrial speed. If you aim that power at trivial problems, you will get trivial results faster. If you aim it at real problems, you can compress decades into years. And the next step in this story is already visible in the announcements: physical AI models, robotics platforms, simulation ecosystems, and the continued acceleration of the AI factory stack. The only question left is whether you are going to treat this like entertainment or like the beginning of a new operating system for the physical world, because once the operating system is installed, it is very hard to uninstall.